All right, guys, so we're going to be looking here at the review for the Estimating with Finite Sums test. Just like on the other reviews, some of the problems I've already done, so I'm just going to show you how to do them as well as make a few comments. If you need to pause it anytime, please do that. So here we go, hopping into review for Estimating with Finite Sums. Now, on the first one, I kind of drew the picture as to what's going on, and it's not incredibly accurate, but we're going from -2 to 2 with 4 subintervals using a left Riemann sum. Now, remember, that's just 4 rectangles of equal length, and so what we've done is there's 4 rectangles. All of them have a base of 1, and then the height I just determined by plugging in the value that I have at 2, 1, 0, or -2, -1, 0, and 1. When I add all those together, if you want to add them up, it adds up to 14. And again, that one's pretty self-explanatory. Just remember you're using rectangles on a Riemann sum. The next one, ln, you're going from 1 to 7 with 3 subintervals. So you're going from 1 to 3, 3 to 5, 5 to 7. So the base on all of those rectangles is 2. And then what you have to do is plug in those various numbers with a right Riemann sum. That's why this is the ln of 3, the ln of 5, and the ln of 7. So you add all those together, and I could have put decimal numbers for each of those as well, and you would have been totally fine with the height. Either way, I just didn't type it in initially, then I got 9.308 in the end. This one I actually think I made a little too hard for the review, but we're going from 0 to pi, which meant and we've got 4 same intervals. We're going to go from 0 to pi fourths, then pi fourths to pi halves. And if those numbers look weird, that's like 0.707, then 1 point, I can't remember what it is off the top of my head. Anyway, you could use the decimals on those as well. Then you have to go halfway between each of those numbers, and when you do that, you get all of these values right here. Notice as well that all of the rectangles have a base of pi fourths. Again, that if you want to put that into your calculator, when you do pi divided by 4, oh, it's 0.785, excuse me. 0.785 is pi fourths. And so that's where all of those, I mean, again, if you wanted to use 0.785 each time and then add that much more, that'd be fine. I believe this one's a little bit more difficult than one I would put on the test itself, but hopefully that kind of makes sense where we got that one. So here's the next one. For the following information, use Riemann sums to estimate the distance traveled by Cool Ranch on his trip to Middle Earth to throw his Beyonce fan club ring into a vortex of lava on the given time interval, given the velocity measured in miles per hour and the time is measured in hours. So the first one says, estimate the distance traveled on the time interval from 0 to 22 using a right Riemann sum. So again, we just look at each of the intervals that we have. The first interval goes from 0 to 1, so it's 1 wide. And then since a right Riemann sum, that's going to be 7 tall. Then we do the next thing, 1 to 4. That is 3 wide and 12 tall. The next one's 1 wide and 4 tall. And we just continue on doing this the entire time. So 5 to 19, that is 14 wide. And since it's a right Riemann sum, it's 2 tall. The 19 to 22 is 3 wide and 1 tall with our right Riemann sum. And you can add all those together if you want. You can leave your answer like that. That's totally fine. On the next one, it wants the average speed. Now, the average speed, what we're going to do, we're going to use a left Riemann sum, and we're only going from 1 to 19. And that's one thing that's important that you realize is we've shortened our interval here a little bit. So from 1 to 19, the first rectangle is going to be 3 wide. Since it's a left Riemann sum, it's going to be 7 tall. Plus, the next one from 4 to 5 is 1 wide, and this one's going to be 12 tall. Plus, the next one is 14 wide and only 4 tall. So there's my 3 subintervals. That gives me my distance that I'm going. And so then I have to divide that by how long it took. 19 minus 1 is 18. And whatever you get there, that would be the average speed. If you want to leave your answer like that, that works fine as well. On numbers 6 and 7, all we had to do was we're doing trapezoids. So remember, it's 1/2 base 1 plus base 2. Base 1 and base 2, what those are how far, those are the y values at each of the different x values that we are looking at. Okay? So I've got those. And then on number 7, you have to be careful because you're going from 2 to 8, but we're still making 4 subintervals. So you'll notice that each of those are 1.5 tall. Then you just plug the numbers in, and then you add all of them together, and whatever you get on both of those, again, I'm not entirely sure, you can put those into the calculator and find the answer there. On number 8 and 9, we're doing pretty much the same thing we did before, but we've got backbreaker driving his car while delivering tacos to non-believers, whatever that means. Estimate the following values. And so we've got, use the trapezoidal sum from 1 to 8. Now again, we're only going from 1 to 8, not 0 to 8. So what I'm going to have to do is I'm going to have to go 1/2, and we're trying to find the displacement, so we go 24 plus 56, because those are our two bases, multiplied by how far apart the time values are. And then we just repeat again and again, 56 plus 85, and then we multiply that by 1 plus 1/2 times 85 plus 112. We multiply that by 2, and then we go 1/2, 112 plus 4, and we multiply that by 2 as well. And that is our trapezoidal sum. Now the average speed on number 9, we're going to take all of those values, so we're going to take all of that, and then we're going to add on to it our first trapezoid that we had. So that's 1/2, and that's going to be 0 plus 24, and then that's going to be multiplied by 1. Then we would divide all of that by how long it took. We would divide by 8. So remember, average speed is displacement divided by how long it took. Displacement is just how far it is from where it started, and we find both of those using these trapezoidal sums here. Here's another one. The following chart gives the rate at which Casey Kasem loses members of Madrigal's or People 2 fan club in fans per minute, measured over a 6-hour time interval. So this is what would the trapezoidal approximation give an approximation of. Now realize again, this is not a number answer. I don't want to know what this is. We'll do that in number 11. Instead, I want to know what is it that I am trying to find right here. And hopefully you can see this trapezoidal approximation gives us an estimate of how many fans Casey Kasem loses. So I've got Casey Kasem loses on that time interval. That's what that trapezoidal approximation tells us. It's not a number answer if it wants to know what it is that it's approximating. The trapezoidal approximation itself, we just have to do 1/2 times. We just make our trapezoids on each different interval, and then we multiply by how wide the interval is. 1/2, I'll just write these out real quick, 900 times 2, plus 1/2 times 900 plus 2,000 times, 2,000 times 1. And I got one more, 1/2 times 2,000 plus 7 times 1 as well. And whatever that adds up to, there's your trapezoidal approximation for number 11. Now on 12, 13, and 14, what we have to realize is we're going to be using shapes to find out what the area is under each of these curves. So the area from 0 to 2 here, I notice that that is a triangle. So I just go 1/2 base times height. The base is 2, the height is 8. And if you put that in, I guess you get 8 as your area there. From 0 to 8, what I notice is I've already got that triangle that I started with, so I could go 1/2 times 2 times 8. Then I could multiply that by this rectangle that I have. The rectangle goes from 2 to 8, so it's got a base of 6 and a height of 8. So I could add those together. I get 8 plus 48 gives me 56 if you want to add them together. Then if we go from 4 to 14, that's a slightly different shape that we've got. So from 4 to 14, I would say we've got this rectangle here, then I got a trapezoid here, and then another rectangle right there. So the first rectangle goes from 4 to 10, that is 6 wide, and then it is 8 tall, so there's my first rectangle. Plus, then I've got this trapezoid here, so I'm going to go 1/2, base 1 plus base 2 is 8 plus 4. And then we multiply that by how wide it is. It's 2 wide, because that's what every tick mark is. Then on the last one, we have a little tiny 2 by 4 rectangle. And if you want to add all of those up to find out what that adds up to, that is fine as well. We would just add all of those together. Lastly, I want to find the exact value of the integral from 2 to 4 of x minus 2 plus 5. Now that, if you graph that on your calculator, what has happened is we went forward 2, and then we're going 1, 2, 3, 4, 5. This would look like this right here. Okay, so we would have ourselves a nice, what's formed from 2 to 5, or 2 to 4, excuse me, is a nice trapezoid. So I would just go 1/2 times, when I plug 2 in, I get 5 as my base 1. My base 2, when I plug 4 in, 4 minus 2 is 2, plus 5 is 7, so there's my second base. And then those two are 2 apart. If you want to leave your answer like that, that's fine. If you want to say that the answer is 12, that is also fine. I do again believe that this is one of the easier reviews that we've had, just because we're finding areas of fairly simple shapes the entire time. If you have any questions about how we got the answer to any of these, please let me know.